This is the Energy Comparison of Fuels lab, and in this lab, I'm going to actually zoom in on what you're going to ultimately be doing in the lab. You're going to have a container that has isopropanol on it, and you're going to put it in there, and you'll know the mass of the isopropanol by the time you get this set up. And you're going to have water in a container, and you're going to know the mass of the water because you're going to have filled both of those and weighed them. So you're going to know the mass of both of those. And what you're going to do is you're just going to turn it on. It's going to be burning. You're going to time yourself for 5 minutes. The 5 minutes part is just to be really fair and even because you're going to let the candle burn for 5 minutes also. After 5 minutes, your temperature is going to go up, right? Because you're adding heat, so the water's getting hotter. So you'll have a delta T value. And you already know the C of water is that 4.184. Quick note, in this lab, instead of the 4.184, there's a calorie version of the C that they want you to use. They want you to use, it's actually an easier number, 1 calorie per gram degree Celsius. So you're actually going to be using this value for your C value for this lab. All right, so back to the water. You know the mass, you know the delta T, and you know the C. So if you know all that, you can figure out the Q of the water. And then, because you know the Q of the water and you know it came from the isopropanol, that will let you know how much energy was lost from the isopropanol. And that's kind of the point of this. They actually are going to have you do it Q per the mass. So you can find out like which one is more efficient, like which one gives off more energy per amount of mass. And when you finish that one, you're going to go to this one and your candle's going to heat up the water for 5 minutes. And note, this is new water, not the same water. If you try to use the same water, you're probably going to get a different measurement because it's going to be a little warm. You need them to be like right at that same temperature. So you'll know your initial and then your final temperature of your water. So you'll have your delta T. And then you know the C, but don't forget to use the 1 calorie per gram degree Celsius. You can put those numbers together so that you end up with the Q of water in this case. And then you know positive Q is equal to negative Q for the candle. So you'll have that value. And so you'll figure out, again, how much energy was released. So that's the point. That's what you're doing in the whole lab. There's one tiny little part at the beginning where you weigh some water, and then that's it. So it might not be all flashy, but this is a kind of an interesting lab because the concept is trying to figure out what kind of fuel is efficient. And you know, we've got octane fuel that's used, we've got diesel fuels, we've got propane. There's a lot of fuels out there. And so knowing why we use different fuels for different things is actually interesting. And you know, you might look more into this. But right now we're just testing a candle versus some isopropanol. So we're going to, when you're looking at this, you're going to be looking at some information about combustion, which is just burning something. So that's not a new term. Totally. You've seen all this before when you looked at types of reactions. And a little bit about biofuels and fuels. And then we go back to this Q equation. Oh, wait, that's in a second. They're actually showing you something about the shapes of molecules. You don't have to know how to draw molecules. But you do have recognized that the picture for butane on the left looks really different from the picture of the acetylene on the right? They look different. The way they look is tied into how efficient they are with releasing energy when they're burned. And then these are the structures between isopropanol and paraffin wax. Paraffin wax is the candle. It's that little tea candle. So you can look at those and you can say, oh, those don't look the same. The isopropanol is shorter. It kind of branches out. The paraffin is long, straight chains. So that has to do with once you figure out which of these is more efficient, this one or this one, you can look at it and you can be like, oh, that's because it's long and lots of carbons, or that's because it's short and it's all branched. So you're going to find out that information. These kinds of pictures are what you see in organic chemistry, by the way, if you end up taking organic chemistry. Here's our Q equation. This is the same Q equation we're used to. It's just their mass is in the middle instead of on the left. I like the mass on the left because then it spells the word MCAT and it's really easy to remember. The A being the delta T, of course. And they kind of mention it. Q, energy transfer, delta T, mass, and then you've got your specific heat. And you can see right there, again, that they want you to use the 1 calorie per gram. And the amount of energy released per gram of fuel, that's the final calculation. So they want you to take the calorie on top and they're going to have you divide it by the total mass. And again, the larger number of the two is the better fuel, so to say. Materials wise, you do need to make sure you've got your aluminum foil, you've got a pie pan, and matches because you're burning. And then you're going to go back to needing that distilled water that you bought for an earlier lab. Hopefully you still have it, as well as the isopropanol you bought for an earlier lab. You're going to need, I don't know, like 60 mils, I think, of it. So you want kind of, I mean, not a ton of it, but some. All right, and then we'll just go ahead and look through the lab and see what you're actually doing in the lab. All right. This first statement is actually about to be fixed. You're not measuring out cold tap water. You're using distilled water. First, you're going to heat it with isopropanol, and then you'll get a fresh sample of the distilled water, and you'll heat that with the candle. So it's kind of slightly off. That statement's kind of slightly off. Again, just like anything, when you're burning something, you don't want to be by a fan, AC, wind, you don't want to burn it out in that 5 minutes. Or to somehow push the heat in a different direction. You want to make sure you record your scale measurements to the hundredths place. We've said that a ton of times. You're going to have a picture of the left thing. You're going to have a picture of the right thing. And you're going to have a picture of 3 different types of calculations. Note that you're going to do a Q calculation for this one and a different Q calculation for this one because they're going to have different amounts that they've changed in delta T's. And then you're going to do a Q per mass. It's just dividing the Q by the mass of the fuel and the Q divided by the mass of the fuel. So it's not like a hard calculation there. It's just a division. And so you're going to need to have all those calculations and pictures of them. And we've got a few steps and tips, calculating density, why you're doing it. In the first part, it seems kind of weird to do it. Tips on the aluminum foil, wrapping it. Make sure you record that thermometer reading up to the right number of sig figs. There's a hint down there. Again, it's the thermometer. Make sure you've got fresh water, not the same water you just heated up. And then there's some tips on doing the calculations. Also, some pictures. As always, start off with your gloves and your goggles. You're going to use a digital scale, and you're going to tear a graduate cylinder on it. So basically, here's our scale. Zoom in a little bit. And I'm going to grab our graduate cylinder. Pretend this is empty for now. You might be able to see it looks like it's got some in it, but pretend it's empty for now. So you're going to take this, you're going to put it on top of it, being empty, and you're going to push that tear button. And when you do, it's going to set the scale back to 0 with the graduate cylinder still being on it. So that's the first thing you do. And then it says use a pipette to add distilled water to the graduate cylinder. So we're going to take that off for a second. So here's our water. And if you remember, so I think this might be hard to pour, depending on how full your distilled water is. You might want to pour it into your beaker because it's got the nice little lip there, and then pour it in here. But here's the other reason, is because you're going to probably pour in like 8 mils, because this is really hard to get exactly right. And then you're going to get your dropper, and I don't have a picture of a dropper, but it's kind of pointy, and it's got like the little bulb at the end of it. You're going to get your dropper. And this is why I was saying, if you pour some water in the beaker, right there, pour it in. Make it blue. So you got some in there. And then you put some of that in there. What you have left over, you can really easily access it with that little pipette, get a few more drops, and actually make it line up so that it really is right at that 10 milliliter marking. You do need it to be the 10.0 milliliters. So now that that's filled up with water, and remember the scale is going to be reading a really weird number right now because you had teared it, set it equal to 0 with the graduate cylinder on it. But when you put it back on, now you're going to have a nice number. I'm making this up, but let's say that your number was 11.1 grams. And remember, it had 10 milliliters in there. It wouldn't be 11.1 though, it'd be 11.11 because that scale reads to the hundredths place. And then the question, after you get it all on the scale and you record the mass, it says calculate the density of water. Now, as a little side note, you should know the density of water is 1 gram per milliliter by this point. However, that's like super pure, super awesome, amazing water, and your water probably isn't like that. So density can be a little off depending on what's dissolved in the water. So they just want you to do it again. So that's your mass, that's your volume. So it's just mass divided by volume. So if I do that calculation, I do 11.11 divided by 10.0 0.0, and so that's going to give me that the density is 1.11 grams per milliliter. This is actually a number you're going to use later in the lab, so don't forget about it. But they're just like, hey, you're going to calculate the density of your distilled water. You're like, okay, whatever. That's all that part is. All right, now we're getting into the setting up of something. And if you've never set up a fuel canister before and it makes you nervous, don't worry. There's not a lot to it. It just looks complicated, but it isn't. So you're going to put your thing back and you're going to re-tear it so that it's back at 0 because you don't want it to have that, you don't want the graduate cylinder in it. So now we're on part 2, and this is where you get to fill up the isopropanol container, the fuel container, which is kind of cool. And so you're going to turn on your digital scale. You're going to want to make sure that you tear it because you don't want the mass of this saved in there at this point because you're working with a fuel canister in this section. So you're going to go and you're going to get your canister, and at the moment it's going to come with the cap on it. So it's going to be picture A. All right, so you want the cap off of it because you're not going to do anything with the cap on it. So you want the cap off. However, it's got stuff inside. It's going to have that wick and that brass thing. It may be separate or it may be all together. Let me see if I can get it zoomed out here. Right here. So it may be separate or it may be through it. Eventually you're going to have to be through it, so you can go ahead and stick it through. But here's the deal, is that you need to get this on the scale, and you don't want just the can part of it. You don't have to have this sticking out the top, but you need to have those two things, but not the cap in this measurement. So it's empty, but it has the little brass thing and it has the wick in it, but not the cap. And you're going to get there and you're going to get that number. And so we're going to just make this up and we're going to say that this is 20.0 grams, 0.00 grams. Yay, you've got that. Oh, and while you're on it, you might want to tear the scale just to have that teared, but always write that number down that you got. Okay, now you can take that stuff back out because you're going to fill it up. So you're going to use your plastic funnel in the opening. And you're not just going to pour it in. You're going to actually need the exact measurement of it. So let me move this out of the way. I'm going to come over here to our graduate cylinder again. There we go. Now this time, what they actually want is they want a total of 30 in the fuel canister. But this graduate cylinder y'all have, it only goes to 25. But if they want 30, the way they have you do it is they have you fill it to the 25. And they're going to have you dump that in, and then they're going to have you fill it to the 5 marking, and they're going to have you put 5 more in. I know, right? Why not do this 25? It has to do with we need your temperature. You need to have enough fuel in there to have your temperature change by a certain amount to get your calculations good enough. So anyways, you got your graduate cylinder. You're filling it up. I can't get that other line to go away. With this time not water but isopropanol, because if you put water in a fuel canister and you try to burn it, it's not going to happen. So you need isopropanol. So boom, there we go. We're putting the isopropanol in. We'll make it purple or maybe dark blue. Nope, purple. All right, so we're going to fill it up, but remember, you're not actually going to quite fill it to the very top because you're going to put some of this in like a little beaker or something like that, and you're going to get your dropper out. And you're going to use your little dropper to get some out of the beaker. And then you're going to put it in here just to get it to that 25 milliliter mark, so you're not way past it. All right, so we're good to go. We got it on there. We're going to come over here to our fuel canister, not with the wick on. We took the wick out because you can't fill it. It's going to have a funnel. So here's our funnel. Make sure you don't pour this too fast. You're going to bring it over here. And you're going to pour that 25 milliliters in. So that should be in. And because they want it to be at the 30 mils, you're going to go back to your scenario with your isopropanol. This time, you're only going to put 5 mils in. You're going to use the dropper to get the last bit of it in there. And once you're sure you're at the 5 mark, you're going to come over here to your fuel canister. And you're going to put your last 5 mils in so that you have a total of 30 mils in there. And you're going to make a little note to yourself or something saying, hey, I got 30 mils in there. All right, now once you've got the 30 mils, guess what? You're going to put your canister together. Woohoo! So we're going to magically pretend that I stuck the wick and everything in it, and that this is now filled up with my isopropanol. Right there. Let me zoom in. So there we go. We're at 20. But we're not at 20, right? Because we just filled it up. So now it's going to have more of a mass. But if you remember, I tiered this. You don't have to have done that. It's totally fine if you didn't, because we know the mass of everything being empty. But if you did tear it and you set it on there, now the number that's going to be on there is just going to be the mass of the isopropanol. So if you notice right here in step 9, determine the initial mass of fuel by just subtracting the mass of the canister from the mass of this number. So if you didn't tear it, let's say that this number came out to be 40. If you know the canister and its extras are 20, then you know that the amount of isopropanol in there is 20 grams. So that's basically what you're going to do there. All right, now you get to actually do the fun stuff. And don't worry, the candle one is way easier because you don't have to. All right, so you're going to now fill up your beaker. Again, with the why don't we have the right size graduate cylinders? I don't know. We have them in our lab. They're not the cheapest thing in the world, in all honesty. So you're going to get your beaker. Yours is supposed to be 250. I know, mine is just a 100. That's the one. Pretend that this is a 250. 250. There we go. Now we magically have a 250 beaker. Move that out of the way. So now we're going to take this, and this is the part where we're going to use the distilled water. And it wants a total of 100 in there, but you have a 25 milliliter graduate cylinder. So you'll do 1. Then you'll do another 1. You getting the sense here? Fill that up. You get it filled up to the top, and then you're going to get it in there. And you're going to do that a total of 4 times until you're up to 100 mils. So hopefully you're good to go on that part. And because you calculated the density up at the top, remember we calculated that density, I think it was 1.11. If you put 100 mils in, 9.0, remember the density you calculated, in my case, and yours won't be this number, so don't try to use it. It tells me that I actually have 110 grams. No, not 110. 1.11 times 100. 111, yeah. Brain moment there. So you do know the mass of the water right here by doing that extra little calculation. So that's why they had you do that. I know, why not weigh it? I know. Maybe it's just good practice for you. So now you're good. You're going to set up, this is steps like 24 through 30. 24 through 30, you're basically setting this up. So and again, remember, I know the mass is like, 111. And I know my C value already. I'm just trying to get my change of temperature. Make sure that you have a normal initial temperature. It should be like around room temperature. So, I mean, it's not going to be exactly, but, like 25-ish, somewhere in that range. So don't use 25 because it's a bit too warm right for room temperature. But that's going to be your initial. And then you're going to heat it up. Let me not get too far ahead of myself. Make sure you're careful about your wick, your candle, when you light it. You're not going to try to light it while it's underneath. You're going to slide this out and then light it and then slide it in. You are going to have a timer actually running. You're not going to estimate this. This is super important that you do this for the exact same amount of time for both of them for a fair comparison. After the 5 minutes, you're going to extinguish the canister flame. And notice you're going to use that little cap to do it. All right, so here's the other thing. You're going to want to get that, you're going to feel like you should get that second temperature reading immediately and you're good to go. However, just like, you know, anything on a fire or anything, like one part of it's going to be warmer. It's going to be way warmer on the bottom than the top. So they actually want you to stir it. So I'm going to grab, and they're okay with you using the thermometer to stir it actually. But you're going to unwrap your foil. And as a little note, I like a little more foil on these. I think that it should go up a little higher on the thermometer. I feel like it should go down lower there. Just don't have it to the point where the flame is actually going to corrode the aluminum. But you'll take all that off. You're going to take your temperature, and you're going to kind of stir it up and just kind of watch that reading. So first watch it. It's going to go up some more after you stir it, and just keep watching it until it stops going up anymore, and that's when you take your reading. So I'm going to just, again, totally making this up. I don't know what the number should be. Let's say that your final temperature is 30. So now you know your delta T is your 5 degrees. So again, you can use Q equals M times C times delta T. And you can get your Q value, which is the amount of energy that was added in to the beaker. And if you want to do the calculations now, you can. But personally, I think it's a good idea to go ahead and finish up the experiment and then go back and do the calculations. So we're going to repeat. Again, fresh water. Take your beaker. You don't want to use that same hot beaker. If you've got a second beaker, that would be better. So basically, you want everything baseline reset. You don't want a hot beaker because when you put your water in it, it might mess up your initial reading. So you are going to place your tea candle on the scale, and you are going to record the mass of your little tea candle. Again, that's the paraffin. And this, they're using that's that test tube holder. They're using it to help get it closer to the beaker, the beaker. And so you're going to have that ready. You can use the match. You don't have to move this one as much, but I think it's easier to light it still if you have it slid out and you light it and then you light it back in. So keep going. Again, set your timer for 5 minutes. Don't forget you're going to have that initial reading. But worst case scenario, you don't have it. You can take your candle out, blow it out, wait like 10 minutes till you are at a new baseline temperature and you have it all stirred up. And then you can basically re-perform the experiment. But it's better to not have to do it that way. And then when you're done, you'll just let your beaker cool, pour your water down the drain, remove that metal cup. You can use the metal cup to extinguish the candle, record the final mass of the candle. So yeah, because you're going to need to know how much of this was burned. You actually have that step in here, and I didn't actually say it, but after you're done with everything, and this would be how much you started with. After you do the whole experiment, you're going to go back and you're going to put this back on here. It's going to have a lower number. So maybe it becomes, like 15. So when you subtract it, you'll get the difference. So that's how much mass of the isopropanol was burned. And then we've got the final calculation right there. So it's kind of weird because it feels like it's an over explanation for something that's actually kind of simple, but just don't want anyone to be confused on any of the steps of it. So hopefully that helps, and it's going to really help you get a sense for calorimetry.